The Norse people thought that the lights were a bridge to Asgard, the home of the gods. Inuit people believed they were the campfires of their ancestors. And ancient people in Finland thought that it was the Archangel Michael fighting the devil in the sky, the eternal battle for good over evil. We now know, thanks to 17th century astronomer Galileo Galilei, that this is the Aurora Borealis, the Northern Lights. Aurora Borealis translates in Latin to the dawn of the north. I've always been fascinated by this phenomenon, and I've recently done a great deal of research in order to give you this presentation today. There are three main processes that we need to understand in order to understand how the Northern Lights are created. First, we need to understand how storms on the surface of the sun eject plasma that travels towards Earth. Then we need to understand how this solar wind that is ejected from the sun is filtered through Earth's magnetosphere towards the poles. And finally, we need to understand what chemical interactions take place once that solar wind reaches the poles. The first point is our sun, the first thing that we need to understand. Our sun is a star that is 4.57 billion years old. Its surface is millions of degrees Fahrenheit, and storms on the surface of the sun smash hydrogen atoms together with such force that nuclear fission takes place, and this creates plasma, the fourth state of matter. This plasma is ejected into space during these violent storms on the surface of the sun, and they travel towards Earth. This phenomenon is known as solar flares. Once that storm has been traveling for 6 hours, it passes the planet Venus. After it has been traveling for 12 hours, it passes the planet Mercury. And after 1 day of traveling, it finally reaches Earth. So what happens once it reaches Earth? Well, if this solar wind were to hit the Earth with full force, it would extinguish the human race. So why hasn't that happened? Why are we still here? This is where we need to understand the Earth's magnetosphere. The Earth's core is filled with molten iron, which creates a magnetic effect. And if you would think about it this way, there is kind of a force field around the Earth, sort of waves, if you will, like this. The Earth's magnetosphere is weakest at the poles. It protects us out here from flying space debris and harmful radiation from space. But of course, it's weakest at the poles. This force field kind of has the effect of funneling this solar wind towards the poles where the magnetic field is weakest. So what happens once the solar wind has reached the poles? This is when the magic starts. The third and final process that we need to understand is what happens once this solar wind has reached the Earth's atmosphere. When the solar wind reaches the Earth's atmosphere, the electrons on the solar wind interact with particles in our atmosphere, the most common being oxygen and nitrogen. This is where the magic takes place. The energy that caused these particles to travel millions of miles is transferred to these particles within our atmosphere. When an atom becomes excited, these fields around the atom expand. When they contract and release that energy, these fields become smaller, and a particle of light called a photon is released. Now the color, and this is the Northern Lights, the color of the light depends on what particle is releasing the photon. Oxygen gives us our greens and blues, which are our most common colors in the aurora. And nitrogen gives us the reds and purples. Of course, these are less common since oxygen is the most common particle in our atmosphere. This happens constantly, not just at night. However, during daylight hours, the light from the sun outshines the photons being released, and we can't see the aurora. In fact, according to NASA scientists, the aurora is about 1 million times dimmer than regular everyday sunlight. In conclusion, there are three main steps in the creation of the spectacular show that we see as the Northern Lights. First, particles from the sun are ejected into space where they travel towards Earth. Once they reach the Earth, they are funneled into our atmosphere at the poles. And lastly, these particles that have managed to make that journey interact with particles within our atmosphere, giving us a feast for our eyes. I hope that if you ever decide to travel to see the aurora for yourself, that understanding the science behind the show will not diminish the beauty of it for you. On the contrary, I believe there is beauty in understanding how the world around us works. I hope that the awe that you would feel would be similar to what the Norse people felt when they thought that it was a bridge to the gods. Thank you.